Welcome to Space to the Ground, and welcome to my house, the Christopher C. Kraft Mission Control Center at NASA's Johnson Space Center. In just a few weeks, it will be from this very room that flight controllers will oversee the Artemis 1 mission, the first of a series of flights that will lead to the return of humans to the surface of the moon.
And liftoff.
For over 20 years, the International Space Station has served as a low Earth orbit platform for human space exploration, scientific research, and technological innovation. Now, the orbiting laboratory is leading the way for the next generation of space stations and moonwalkers. NASA is looking towards a return to the moon through Artemis, where we will explore more of the lunar surface than ever before. Building on a history of operating a space station in low Earth orbit and with collaboration with commercial and international partners, Artemis will establish the first long-term presence on and around the moon. A vital component of Artemis is a new, state-of-the-art space station dubbed Gateway. Gateway will serve as an outpost for astronauts as they go between lunar orbit and the lunar surface. Gateway will also allow for the remote support of the Artemis base camp as our future robots and astronauts explore further and conduct more science than ever before. Gateway will remain in orbit for more than a decade, providing a place to live and work, and supporting long-term science and human exploration on and around the moon. To learn more about the Gateway Space Station and how it has grown from the lessons learned with the International Space Station, we are joined by Sean Fuller, the International Partner Manager for the Gateway program at NASA's Johnson Space Center. So one of the things about Gateway is that it's building on the International Space Station. What kind of lessons learned are you taking from the ISS for Gateway today?
Yeah, that's great. And we got a lot of folks working in the Gateway program, like myself, that have a history in ISS. Also have our crews. So it's great that the crews that have spent time living on ISS that can translate that into Gateway for us to think about it. So lessons learned we have in there, when we really think about the layout inside of Gateway, it goes into the small things, the computers that the crew uses. How can we condense that down to the numbers of laptops and interfaces on Gateway? We see a lot of equipment externally on ISS. That would be a harsher radiation environment for us in Gateway. Different design concepts. A lot of ours is internal in equipment. Computers, for example, are all internal. We bring a lot of that stuff inside. And so we take those lessons learned. Probably one of the biggest areas we apply to it, though, because it's crew tended, is think about reliability and maintainability, because the crew's not there. We've learned a lot of great lessons on ISS. We often reference AMS. We did some great EVAs, did some stuff on there that when we launched AMS, never envisioned doing.
All right, gentlemen, Luca, if you need it, it's a clocking of 6 when you get back.
That is a big lesson learned out of ISS. So in other words, in the beginning, it doesn't necessarily need to be fully designed to be replaceable, but give us those tools, those interfaces, and with this great team, we'll figure out a way to do that in the future.
So I know with the International Space Station, we do have mission control centers all over the world, and we have international partners. So how many countries are we working with Gateway?
Gateway is really building off of the International Space Station and that cooperation. So we have on Gateway today is NASA. We're leading that. Our European colleagues are with us, building a couple very important elements for Gateway, both habitation as well as a module that will provide refueling, on-orbit stowage, very important for us. Crew viewing, so they'll be able to look out, see the Earth, see the Moon. That's where it'll happen on a European module, as well as a comm system that will launch early on Gateway is from our European colleagues. Canadians, big surprise, Canadarm3. So building off of the first Canadarm on the Space Shuttle, Canadarm2 that's doing so well on ISS today, the third evolution of that on Gateway, Canadarm3, along with all the great external robotic fixtures that'll have our science on it, it'll have ORUs across Gateway. So very similar to ISS, kind of expanding that to Gateway. And then our Japanese colleagues at JAXA, they'll be building the life support system within the European ESA IHAB module. And also we're about to launch HTV-X next year for ISS, the first one of those. We're looking at that evolution to an HTV-XG Gateway version. also as logistics resupply. Like you said, on ISS, we've got control centers around the world. We're going to have centers around the world. We're building hardware around the world today. We're going to operate Gateway a little differently, though. We're not 365, 24/7 with crew on Gateway. We're doing that with crews that come up on Orion for the landing missions. So we look at about 30 to 60 plus days, depending on a logistics train, of crews there. So we'll have centers of those places that I mentioned supporting during the crewed time frames. But as during the uncrewed phases, I don't foresee on teams on console around the world, probably more of like an on-call type situation. A lot of stuff can be going on Gateway, but we won't have the crew there. So that lets us operate in a little different realm.
When it's dormant, are we getting any telemetry, or do we know how that
we'll
works?
have great capabilities, and so we'll flesh out exactly what that ops concept is. So early on, right, we launched the first elements called the co-manifested vehicle. PP and Halo will launch together. We'll go through a checkout phase. That's a more intense operations team and engineering team as we check it out. Then as it spends about a year getting out using the solar electric propulsion, new technology to get us out there, we'll look at it and do more of a skeleton crew type things. One of the things we're also baking into Gateway early on is our software and software management. We call it the Vehicle Systems Manager. It'll have opportunities in the future to look at autonomy and factor autonomy in there. Kind of a crawl, walk, run type scenario. And so you start out with small pieces, and we look at that to evolutionize in the future so that we can minimize the on-console demand, if you will. I don't know that it'll ever go to zero, but we'll have great systems that'll alert us. We'll have comm coverage with our deep space network. Actually, one of the unique things about Gateway and its orbit, NRHO, we're kind of always looking back at the Earth. And so we'll have those comm opportunities quite frequently.
That'll be great, because that's also going to give us a lot of information about how to do this when we go even further, maybe onto Mars, and have Mission Control support those missions. That's
exactly right, and I'm glad you mentioned that. This is kind of our stepping stones for it, right? So we're building it and doing it in a sustained manner for lunar exploration, and so that's what Gateway lets us do. Gateway is that hub. It's kind of that last outpost before you go off on your hike and you come back to and get resupplied. But then we'll also look farther, right? This is Moon to Mars. What are we doing on the Moon to help us for that Mars exploration? And Gateway is going to be central to that. As we look at ISS today, it's a lot different than when we launched that first element, doing a lot of things on ISS that we didn't dream of back then. We keep that in mind with Gateway, recognizing we're going to do lunar surface, but also the expanse to Mars. And so one of the things we talk about is the ability and the capability within Gateway for a Mars transit hab. So that would be on the front end of Gateway, kind of get things checked out. You could do a shakedown run, maybe a year long, in a Earth-Moon type orbit, so before you go off to Mars. Shake that out, come back to Gateway, and then in the future go on to Mars. So we bake that in from the very beginning, keeping it very open, support our mission and our requirements, objectives today, but open to the future as well.
Sounds just as complex as building the International Space Station. Is it going to be bigger or smaller than what we saw in terms of the construction of the ISS?
Yeah, it's going to be quite a bit smaller. And if you think about the role of Gateway, it's an outpost. ISS is 6-7 crew, 365 days a year. Gateway will have 4 crew visiting from Orion. At least the initial missions, 2 of them will go down to the surface on a lander, perhaps all 4 in the future. And so it's smaller. It's about 30 to 60 days with crew there. If I look at comparisons from a pressurized volume, what I like to say is ISS, it's about a 4, maybe 5 bedroom, nice size, very comfortable house. You look at Gateway, it's probably more of your studio apartment size in terms of volume. But our overall mission is different, right? Gateway is supporting that full mission of the lunar surface. We have crews go down there. So we keep all those things in mind as we build the complex.
That's fantastic. Sean Fuller, the International Partner Manager for the Gateway program. Thanks again for joining us today.
You bet, my pleasure.
It's a really exciting time here at NASA, with the International Space Station continuing to grow and expand our knowledge of living and working in space. And now with Gateway, a next-generation station for lunar orbit in development. We will use what we learn on and around the Moon to take the next giant leap, sending the first astronauts to Mars. We invite you to come along as we take those giant leaps and the small steps. You can follow us on Twitter at NASA Artemis and at NASA_Gateway. And that's Space to Ground for now. I'm Kayla LaFrance at Mission Control in Houston. Thanks for watching. We'll see you next week.